Today is January 9th, 2026, and something extraordinary just happened. 48 hours ago, on January 7th, astronomers released a new image of the interstellar visitor 3I ATLAS, an object that has traveled through the frozen darkness between stars for possibly millions of years. An object that formed around a distant sun that died long before Earth even existed. But this image revealed something no one expected. The comet is glowing green, a strange, eerie luminescence that shouldn't be there, and the reason it's glowing tells us something profound about the chemistry of the ancient universe, about the true age of the cosmos, and about just how incomprehensibly vast reality actually is. Because when the James Webb Space Telescope pointed its infrared eye at empty space, it found something that changed everything. It found 800,000 galaxies hiding in what we thought was nothing. Hubble found only 10,000 in the same spot. We've been seeing 1% of what's actually out there, and 3I ATLAS, this ancient messenger from the deep cosmos, is forcing us to confront a truth that most people aren't ready to hear. The universe is bigger, older, and stranger than we ever imagined, and we're only just beginning to see it. My name is David, and what I'm about to share with you isn't just another space discovery. This is a fundamental revision of what it means to exist in reality. For months, we've been tracking 3I ATLAS as it made its journey through our solar system. We watched it approach the sun. We watched it heat up. We watched it vent gases into space as the solar radiation began to cook its ancient ices. And then, on November 26, 2025, the Gemini North Telescope on Mauna Kea in Hawaii captured something remarkable. An image that shows the comet transformed, glowing with an otherworldly green light, its tail streaming behind it as it races away from the sun. But here's what makes this moment so profound. This isn't just about one comet. This is about what happens when you combine the story of an interstellar visitor with what the James Webb Space Telescope has revealed about the true scale of the universe. Because Webb didn't just show us more galaxies, it showed us that everything we thought we knew about how big the universe is was based on catastrophically incomplete information. We were making estimates based on what we could see, and we could only see a tiny fraction. It's like estimating a city's population by standing on one corner at midnight, counting passers-by. Catastrophically wrong. In this video, I'm going to show you exactly what the latest observations of 3I ATLAS reveal, what the green glow actually means, where this ancient object came from, and how it connects to Webb's discovery that the universe is 100 times larger than we thought. By the end, you'll understand why we're living in the only era when the universe reveals itself. You're witnessing something with a beginning, middle, and end. You're alive during the brief golden age when the full story is still visible. Let's begin. On January 7, 2026, the International Gemini Observatory released a brand new image of 3I ATLAS. This image was captured on November 26, 2025, using the Gemini Multi-Object Spectrograph instrument on the Gemini North Telescope. And the first thing you notice when you look at this image is the color. The comet is glowing green. Not the red hue we saw in earlier images from August 2025 when Gemini South captured it. Not the pale white of a typical comet reflecting sunlight. Green, a strange, eerie, almost unnatural green that makes the comet look like something out of science fiction. But this isn't fiction. This is chemistry, ancient chemistry from a dead solar system, now revealing itself as the comet heats up. And let me explain what's happening. As 3I ATLAS approached the sun during late 2025, it made its closest pass, what astronomers call perihelion. At this point, the comet was being absolutely hammered by solar radiation. The ancient ices that had been frozen for millions of years in the cold of interstellar space were suddenly being heated to hundreds of degrees. And when you heat up a comet, it doesn't just melt, it sublimates. The ice turns directly into gas, bypassing the liquid phase entirely. This creates what's called a coma, a vast cloud of gas and dust surrounding the comet's nucleus. But the green color, that's specific, that's diagnostic. According to the scientists at NSF Noir Lab who processed this image, the green glow is caused by diatomic carbon. That's a molecule made of two carbon atoms bonded together, written as C2 in chemistry notation. When diatomic carbon is hit by ultraviolet light from the sun, it fluoresces. It absorbs the UV radiation and re-emits it at a specific wavelength in the green part of the spectrum, around 518 nanometers to be precise. This is the same reason some comets from our own solar system glow green, but here's what makes this profound. The carbon in 3I ATLAS didn't form in our solar system. It formed around a different star, in a different stellar environment, possibly billions of years ago, and yet the chemistry is the same. The same molecules, the same reactions, the same green glow. This tells us something fundamental about the universe. The laws of chemistry are universal. The same reactions that happen here happen everywhere. The building blocks of life, carbon, hydrogen, oxygen, nitrogen, they're the same across the entire cosmos. But there's more in this image that tells an even deeper story. The November 26th image from Gemini North shows something else. Something that reveals just how violent the comet's close approach to the sun actually was. Look at the structure of the coma. It's not symmetrical. It's not a perfect sphere of gas surrounding the nucleus. It's lopsided, distorted, streaming away from the sun in a long tail that extends for millions of kilometers. This is the solar wind at work. Gemini South captured 3I ATLAS. The comet appeared reddish. The light being reflected and emitted was dominated by longer wavelengths. This suggested the presence of complex organic molecules, tholins, the same reddish compounds found on Pluto and Titan. But by November, after the close approach to the sun, the color had shifted to green. The diatomic carbon was now dominating the spectrum. What happened? The intense solar radiation broke apart the complex organic molecules. The tholins, which are made of long chains of carbon, hydrogen, and nitrogen, were shattered by UV light. This released simpler molecules, including diatomic carbon, which then fluoresced green. We're watching the comet being destroyed in real time. We're watching millions of years of preserved chemistry being torn apart by the sun's radiation. And this destruction is telling us what the comet is made of. According to the spectroscopic analysis, 3I ATLAS contains water ice, carbon dioxide ice, carbon monoxide, methane, ammonia, and complex organic molecules. This is the same mixture we find in comets from our own solar system's Oort cloud. But there's one crucial difference. The ratios are slightly off. The abundance of certain isotopes, different versions of the same element with different numbers of neutrons, doesn't quite match what we see in solar system comets. This is the smoking gun. This is the proof that 3I ATLAS formed somewhere else, in a different stellar environment with a different chemical history. Bryce Bolin, the research scientist from Eureka Scientific who led the observation program, said something profound in the press release. He said, "Sharing and observing experience in some of the best conditions available gives the public a truly front-row view of our interstellar visitor, a front-row view." That's what we have right now. We're watching an object from another star system, an object that might be older than our entire solar system, being transformed by our sun. But the scientists also noted something else. Something that hints at what's coming next. The Gemini North observations revealed that 3I ATLAS is now moving away from the sun, heading back out into the cold of interstellar space. As it moves farther away, it should be cooling down. The venting of gas should be slowing. The coma should be shrinking. But the scientists warn that this might not be the end of the show. Some comets experience what's called a delayed outburst. This happens when the heat from the sun penetrates deep into the comet's interior, warming up subsurface ices that were initially protected by the outer layers. Days, weeks, or even months after perihelion, these subsurface ices suddenly sublimate, causing a massive eruption of gas and dust. The comet can brighten dramatically, sometimes by several magnitudes, as this buried material is explosively released. Will 3I ATLAS experience a delayed outburst? No one knows. We've never observed an interstellar comet long enough to see if this happens. 2I Borisov, the previous interstellar comet, did show some outburst activity, but it was relatively mild. If 3I ATLAS does have a major outburst, it would give us an unprecedented look at the interior composition of an object from another star system. We'd be seeing material that's been locked away, untouched, for millions or billions of years. The Gemini telescopes will continue to monitor 3I ATLAS as it recedes. They'll be watching for any signs of unusual activity, any brightening, any changes in the spectrum that might indicate fresh material being exposed. But here's the sobering reality. Every day, 3I ATLAS gets farther away. Every day it gets fainter. Eventually, it will fade below the detection limit of even our most powerful telescopes. And then it will be gone, disappearing back into the darkness between the stars. We'll never see it again. No human will ever see it again. It will travel for millions of years through the void, perhaps eventually entering another star system, perhaps being captured by another sun's gravity, perhaps colliding with a planet and delivering its ancient organic molecules to a new world. But we won't know. We'll never know what happens to it. This is the tragedy of interstellar visitors. They give us a brief glimpse of the wider universe, a momentary connection to the vast cosmos beyond our solar system, and then they're gone forever, unless we understand just how big that cosmos actually is. Now I need to tell you about what the James Webb Space Telescope discovered, because this is where the story of 3I ATLAS connects to something much larger, much more profound. Scientists operating Webb had to decide where to point it. One choice they made was to point it at nothing, at a region of sky that looked empty because previous telescopes found almost nothing there. The Hubble Space Telescope had surveyed this region before. This tiny area, the size of a grain of sand held at arm's length, contained roughly 10,000 galaxies. The Hubble Deep Field became famous, showing how crowded space really was. But Webb was different. It could see infrared wavelengths where the most distant galaxies show up because their light has been stretched by cosmic expansion. So scientists gambled. They pointed Webb at the same region and told it to collect light for 250 hours. 10 days, just gathering every photon, building an image from the faintest signals. When the image came together, it contained 797,942 galaxies. Nearly 800,000 galaxies, every one a collection of billions of stars, every star potentially surrounded by planets, all hiding in what looked empty. Hubble missed 98% of what was there. Let that sink in for a moment. We thought we were seeing the universe. We thought we understood how many galaxies existed, how much matter was out there, how big reality actually was. We were seeing 1% of it. The galaxies were always there. They became invisible because we were looking with the wrong tools. The wavelengths had been stretched beyond what visible light telescopes could see. This is the first lesson. Reality is always bigger than your tools for observing it. The universe doesn't shrink to fit your telescope. Your telescope determines how much you currently perceive. When you upgrade tools, reality explodes in complexity. Emptiness reveals abundance. If we were that wrong about one patch of sky, we're probably that wrong about everything. Current estimates say the observable universe contains between 200 billion and 2 trillion galaxies, but those estimates are based on observations that missed 98% of what Webb found. The real number might be 20 trillion, 100 trillion, numbers so large they stop meaning anything. Every galaxy contains an average of 200 billion stars. Multiply that by potentially 100 trillion galaxies, and you get numbers with more zeros than you can count. Each star might have planets, Earth-like worlds, life's chemistry playing out on uncountable stages. And here's where it connects to 3I ATLAS. 3I ATLAS formed around one of those stars, one star out of potentially 20 sextillion stars in the observable universe. That's a 2 followed by 22 zeros. Think about the odds. That star, wherever it was, had a planetary system. In the outer reaches of that system, in the frozen darkness beyond the planets, chunks of ice and rock coalesced. Just like in our own solar system's Oort cloud, these objects formed a vast sphere of potential comets. And then something happened. Maybe the star went supernova. Maybe a passing star disrupted the system. Maybe a giant planet's gravity flung this particular comet out into interstellar space. Whatever the cause, 3I ATLAS was ejected, and then it traveled for millions of years, possibly tens of millions of years. through the absolute cold of interstellar space, where temperatures hover just a few degrees above absolute zero, through the vast emptiness between the stars, where the nearest object might be trillions of miles away. The Milky Way galaxy is 100,000 light-years across. The space between stars is almost entirely empty. The chances of an interstellar object randomly passing through any given star system are astronomically small, and yet here it is. Out of 100 trillion galaxies, out of 20 sextillion stars, out of the infinite possible trajectories through space, this one object happened to pass through our solar system at the exact moment in cosmic history when we have the technology to detect it, to study it, to understand what it is. If 3 I ATLAS had passed through 100 years ago, we never would have known. If it passes through 100 years from now, we might not care, distracted by other concerns, but it's here now, and we're here now, in the same place at the same time. This is what the scale of the universe actually means. Not just that space is big, but that connection across that space is almost impossible. That the odds of any two objects, any two civilizations, any two moments of awareness intersecting are so small that every intersection becomes precious. We're not just looking at a comet, we're looking at a messenger from a part of the universe we'll never reach, carrying chemistry from a time we'll never see, telling us about a star system that no longer exists. And the James Webb Space Telescope has shown us that there are potentially 100 trillion other star systems out there, each with their own story, each with their own comets, each with their own potential for life. But we'll never see most of them. Let me tell you about distance, because this is where scale becomes impossible to comprehend. Light travels at 186,000 miles per second. Nothing moves faster. The universe is 13.8 billion years old, so logically, the farthest we should see is 13.8 billion light years away. Simple math, except that's completely wrong. The actual edge of the observable universe sits 46.5 billion light years away. Total diameter, 93 billion light years across, nearly 7 times wider than the distance light could have traveled. The reason is expansion. Space itself stretches, not things moving through space, but space growing, creating new distance without objects actually moving. When a distant galaxy emitted light 13.5 billion years ago, it was much closer. But during those billions of years, light spent traveling toward us. Space expanded. The galaxy was carried away by expansion. By the time that ancient light reaches us, the galaxy has drifted to 33 billion light-years or more, and expansion is accelerating. Space grows faster over time, driven by dark energy, comprising 68% of everything. Dark energy causes space to expand, and more space means more dark energy, creating more expansion in a runaway loop that never stops. What this means: some galaxies currently recede faster than light speed. Not because they're moving through space faster than light, but because space between us expands so fast that the total distance increase exceeds light speed. Those galaxies lie beyond the cosmic horizon. Light they emit now will never reach us, because light travels toward us at light speed, but space between us expands faster. This creates a boundary beyond which things become permanently unobservable, forever invisible, impossible to ever see, even with infinite time. Everything within 46.5 billion light-years is part of your observable universe. Everything beyond exists in a separate reality you can never access. And every second, more galaxies cross that boundary and disappear. Right now, galaxies visible to our telescopes are being carried past the edge. They cross the horizon and vanish forever. In 150 billion years, almost every galaxy will be gone. Observers in the Milky Way will see only our merged galaxy with Andromeda, plus maybe 50 small satellites. The night sky will be almost empty. Future scientists will have no way to discover cosmic history's truth. They'll never find evidence of the Big Bang. They'll never realize they're living in remnants of something once vast. We're living in the only era when the universe reveals itself. You're witnessing something with a beginning, middle, and end. You're alive during the brief golden age when the full story is still visible, with some of the last conscious beings who will ever see the universe as it actually is. And 3 I ATLAS is part of that story. Here's something that most news articles about 3 I ATLAS aren't telling you. This might be the oldest comet we've ever seen. When astronomers analyzed the spectroscopic data, when they looked at the ratios of different isotopes in the comet's composition, they found something extraordinary. The deuterium to hydrogen ratio is high, very high. Deuterium is heavy hydrogen, a hydrogen atom with an extra neutron. In the early universe, right after the Big Bang, there was a certain amount of deuterium created. Over time, as stars formed and died, as stellar nucleosynthesis created heavier elements, the ratio of deuterium to normal hydrogen changed. By measuring this ratio, you can estimate when and where an object formed. And 3I Atlas's ratio suggests it formed in a very old stellar environment, possibly in a star system that formed when the Milky Way galaxy was still young, when the universe was only a few billion years old. This comet might be 10 billion years old, maybe older. Think about that timeline. 10 billion years ago, the universe was 3.8 billion years old. The Milky Way was still assembling itself from smaller galaxies. The sun didn't exist yet. Earth didn't exist yet. Life hadn't emerged anywhere in our solar system because our solar system hadn't formed. But somewhere out there, around a star we'll never identify, in a planetary system that's now destroyed, this chunk of ice and rock and organic molecules was forming, and it's been traveling ever since. For 10 billion years, this object has existed, preserved in the cosmic freezer of interstellar space, unchanged, untouched, carrying the chemistry of the ancient universe locked in its ices. Until now, until it passed close to our sun, and that ancient chemistry was finally released, finally revealed, finally studied by beings who evolved on a planet that didn't exist when the comet formed. We're looking at a time capsule from the early universe. We're seeing what the cosmos was like billions of years before our own existence. And the James Webb Space Telescope has shown us that there are potentially trillions of other star systems out there, each producing their own comets, each with their own ancient chemistry, each telling their own story about the history of the universe. But 3I Atlas is the only one we can touch, the only one we can study. The only one that happened to pass through our neighborhood at the exact moment when we could see it. But Webb found something else, something that connects to 3I Atlas in a profound way. Galaxies that shouldn't exist, galaxies that broke our understanding. There's one galaxy, JWST Z14-0, that emitted its light when the universe was only 290 million years old. The universe is 13.8 billion years old. This galaxy existed when reality was barely 2% of its current age, and this galaxy is impossible, too bright, too massive, too organized. It contains hundreds of millions of solar masses worth of stars, all formed in cosmic weeks. Our models say this shouldn't exist. There wasn't enough time, yet there it blazes, existing anyway, indifferent to our theories. Scientists doubted what they saw for months. They checked instruments, verified measurements. Everything confirmed the same impossible result, and it wasn't alone. Webb found hundreds of similarly impossible galaxies, all too large, too bright, too developed for their age. Our models are fundamentally wrong. We thought we understood how galaxies form. We had a timeline that should unfold gradually over hundreds of millions of years. The universe showed us that timeline is fiction. Things happened faster. The infant cosmos was far more active than we imagined. And here's the connection to 3I Atlas. If galaxies formed faster than we thought, if stars formed earlier than we thought, then the star system that produced 3I Atlas might be even older than we estimated. The comet might have formed in one of these early, impossible galaxies. It might carry chemistry from the very first generation of stars, from a time when the universe was still figuring out how to make heavy elements. We don't know. We can't know for certain, but the possibility is there. Every time we look farther, we find things contradicting what we thought we knew. The universe isn't behaving how our theories predict. It's stranger, more resistant to simple explanation. You need to hold your understanding lightly. Accept that what you think you know is probably incomplete, probably wrong in ways you can't identify yet. This isn't about giving up on knowledge. It's about humility, recognizing every discovery is provisional, and evidence keeps changing. Now let me tell you what this means for your place in reality. You live inside a bubble. Your observable universe extends 46.5 billion light-years in every direction. That's the region where light has had time to reach you. Everything inside is potentially knowable. Everything outside is not. But your bubble isn't the same as someone else's bubble. Stand anywhere else and you'd have a different observable universe, overlapping with Earth's, but not identical. A galaxy 50 billion light-years from Earth exists in a completely separate observable universe. We will never see it. It will never see us. We are permanently, physically, fundamentally separated. The universe is fractured into billions of trillions of overlapping observable bubbles, each revealing a different subset of the cosmos. There's no view from nowhere. Reality is inherently partial, and you're trapped inside your partiality. You are cosmically alone in a way you cannot fix. Not alone because life doesn't exist elsewhere. It probably does. But alone because most of it exists in regions you can never contact, never communicate with, never confirm. You could be surrounded by civilizations and still be isolated because observable bubbles don't overlap. From a distant galaxy's perspective, if beings exist there, they're looking back at the Milky Way as it appeared billions of years before you were born. They might wonder if anyone lives here, looking at ancient light showing an era before Earth existed, and you're doing the same in reverse, seeing their deep past while their present unfolds unreachably. There's no universal now, no cosmic clock synchronizing everyone's present moment. Every location has its own timeline. You and that distant galaxy aren't just separated in space. You're separated in time, unable to share a present moment, even in principle. This is what cosmic scale actually means. Distance and time tangle in ways making connection impossible, trapping you in your own moment, surrounded by visions of a past that no longer exists. The star system that produced I ATLAS, it's probably gone now. The star might have died billions of years ago. If planets existed there, they've been destroyed or scattered. If life ever emerged, it's extinct. But the comet survived. It's here. It's the only remaining evidence that that star system ever existed. And we're the only beings who will ever know about it. The numbers Webb reveals are violence against human scale. Your brain cannot comprehend them. When I say there might be 100 trillion galaxies, your brain hears a lot and stops. The number is too big for machinery that evolved to count fruit. Webb forces you to confront what those numbers mean. 800,000 galaxies in one tiny patch, each containing 200 billion stars, each star potentially hosting planets. The multiplication spirals into numbers with more zeros than you can track, and numbers stop being abstract and become evidence of your irrelevance at scales too large to defend against. How do you matter in a universe containing numbers like that? The answer is brutal. You don't. You can't. The universe is too big for your actions to propagate beyond your tiny planet. This is the dark truth. The universe's scale is an argument against your significance. You are small in a way that cannot be fixed, but that move from I am small to therefore I am insignificant, that's not logically valid. Scale doesn't determine value. Your significance isn't measured by what percentage of space you occupy. You are not insignificant because you're small. You're precious because you're rare. Life, as far as we can confirm, is astonishingly uncommon. We found it on exactly one planet. Consciousness is even rarer. The ability to look up and understand what you're seeing might be unique in your entire observable universe. Maybe civilizations are scattered across trillions of galaxies, but you'll never meet most of them. They exist in separate bubbles, unreachable, which means consciousness here, in this moment, is irreplaceable. Not because it's special in some grand cosmic sense, but because it's the only consciousness you have access to. You don't get to be someone else 50 billion light years away. You get to be you, here, now. And that's enough, because the universe has already decided it's all you're getting. Section 11. The green glow. What it means to witness this. Let's come back to that green glow. That strange, eerie luminescence in the November 26th image of I ATLAS. That green light is diatomic carbon fluorescing under solar UV radiation. It's chemistry. It's physics. It's explainable. But it's also beautiful. It's beautiful because it's ancient chemistry from a dead star system, now revealing itself to beings who evolved billions of years after that chemistry formed. It's beautiful because it's rare. We've only seen 3 interstellar objects ever. The chances of seeing another one in your lifetime are small. It's beautiful because it's temporary. In a few months, 3I ATLAS will fade below detection limits. It will disappear back into the darkness, and we'll never see it again. You're witnessing something that will never repeat. This exact moment, this exact object, this exact configuration of matter and energy and awareness will never happen again in the entire history of the universe. That's what makes it precious. Not because it's cosmically significant. The universe doesn't care about 3I ATLAS. The universe doesn't care about you, but you care. You're here. You're watching. You're trying to understand. And that caring, that curiosity, that desire to know, that's what makes you human. That's what makes this moment matter. The Gemini North Telescope captured that image on November 26, 2025. Scientists processed the data. They wrote the press release. They shared it with the world on January 7, 2026. And now you're seeing it. You're learning about it. You're connecting with something that traveled for millions of years just to pass through our neighborhood for a few months. This is the only time in cosmic history when this connection could happen. 100 years ago, we didn't have the technology. 100 years from now, the comet will be gone. But right now, in this moment, you and 3I ATLAS exist in the same universe, in the same time, in the same story. We're living in the only era when the universe reveals itself. Think about that timeline. The universe is 13.8 billion years old. Humans have existed for maybe 300,000 years. We've had telescopes for 400 years. We've had the ability to detect interstellar objects for maybe 10 years. That's a window of 10 years out of 13.8 billion years. That's 0.07% of cosmic history. And you're alive during that window. You're alive during the brief golden age when we can see distant galaxies before they disappear beyond the cosmic horizon, when we can detect interstellar visitors before they fade into the darkness, when we can study the chemistry of ancient star systems before that information is lost forever. In 150 billion years, the night sky will be almost empty. Future observers will see only their local galaxy. They'll have no way to discover the Big Bang, no way to measure cosmic expansion, no way to know that the universe was once full of galaxies. They'll think they live in a small static universe. They'll be wrong, but they'll have no way to know they're wrong. We're not in that future. We're in the golden age. We can still see the full story, but the window is closing. Every second, galaxies disappear beyond the horizon. Every year, the universe becomes a little less knowable. 3I ATLAS is part of that story. It's a messenger from the wider universe, from the parts we can't reach, telling us that there's more out there than we can ever see. And the James Webb Space Telescope has shown us just how much more there is. 800,000 galaxies, where we thought there were 10,000. Potentially 100 trillion galaxies in the full observable universe. Each one a collection of billions of stars. Each star potentially surrounded by planets. Each planet potentially hosting life. And we'll never know. We'll never reach most of them. We'll never communicate with most of them. We'll never confirm they exist. But we can know they're there. We can see the evidence. We can understand the scale. And that understanding changes everything. The scientists monitoring 3I ATLAS are watching for something. Something that might not happen, but if it does, it would be extraordinary. A delayed outburst. Remember, the comet made its closest approach to the sun in late 2025. It was heated intensely, the outer layers sublimated, creating the coma and tail we see in the images. But heat takes time to penetrate. The comet's interior, protected by layers of ice and dust, might still be cold, might still be frozen. But as days and weeks pass, that heat works its way deeper. It warms subsurface ices that were initially protected, and then suddenly those ices sublimate. All at once, explosively. The comet brightens dramatically. It vents massive amounts of gas and dust. It reveals material from deep inside. Material that's been locked away, untouched, for billions of years. If this happens with 3I ATLAS, we'd be seeing the interior composition of an interstellar comet for the first time. We'd be analyzing chemistry that's never been exposed to sunlight, never been altered by radiation, never been contaminated by the solar system environment. It would be like opening a time capsule from the early universe, but it might not happen. Some comets have delayed outbursts, some don't. We can't predict it. All we can do is watch and wait and hope. The Gemini telescopes will continue monitoring. Other observatories around the world will keep their instruments pointed at the fading speck of light as it recedes into the distance. And if something happens, if the comet suddenly brightens, if new spectral lines appear, if the chemistry changes, we'll know. We'll know that we're seeing something no human has ever seen before, something that might never be seen again. That's the nature of these interstellar visitors. They're unpredictable, they're unique, they're precious, and they're temporary. So what do you do with this information? What do you do with the knowledge that the universe is 100 times bigger than we thought? That we're living in a golden age that will end? That we're trapped in an observable bubble surrounded by infinite things we can never reach? Let me offer you something practical. First, look up with different eyes. Tonight, look at the moon. Really look. That's where the moon was 1.3 seconds ago. Find a star. That light is years old, maybe centuries. You're seeing a ghost. This practice is about understanding that connection across distance requires accepting you're always connecting with the past, never the present. At cosmic scales, that gap becomes billions of years. Stop expecting immediate, perfect connection. Accept that knowledge is always partial, always delayed, and find peace in that incompleteness. You'll never have perfect information, and that's okay. You can still love. You can still matter to people within reach. Second, identify the limits of your direct experience. Not what you've been told, but what you've actually perceived. How far have you traveled? How much of your own city have you actually seen? The answer is shockingly little. Most of what you know comes from secondhand sources. You're trusting they're telling the truth, but you can't verify it directly. This isn't about skepticism, it's about humility. Almost everything you believe is based on trust. Your observable universe of certain knowledge is incredibly tiny. Everything beyond that is faith. Notice when you're confusing things I've been told with things I know for certain. Third, witness your own disappearance. Imagine yourself from the perspective of someone 50 billion light years away. They can't see you. You exist outside their observable universe. You simply don't exist to them. Now reverse it. There are beings right now, living complete lives in galaxies you'll never see. Being born, falling in love, dying, all happening simultaneously, and you will never know they exist. Sit with that disconnection. You are alone in a way that cannot be resolved. Not alone because nobody else exists, but alone because most of it exists in places you can never reach. You have to build meaning inside your bubble, knowing your bubble is all you get. You don't get to explore the whole universe. You get this planet, maybe someday this galaxy. Everything else is permanently beyond you. Grieve that limitation. Feel the loss of all those potential connections, all those civilizations you'll never meet, and then decide that the tiny corner you do have access to is still worth caring about, still worth protecting, still worth filling with beauty, because what else are you going to do? The universe decided you can't have everything. The only choice is whether you'll cherish the tiny everything you do have. 3I ATLAS is still out there. Right now, as you're reading this, it's moving away from the sun at tens of thousands of miles per hour. Every second, it gets a little farther. Every day, it gets a little fainter. The green glow is fading. The coma is shrinking. The tail is dissipating. In a few months, maybe a year, it will fade below the detection limit of our telescopes. And then it will be gone. Back into the darkness between the stars. Back into the cold of interstellar space. It will travel for millions more years. Maybe it will enter another star system. Maybe it will be captured by another sun's gravity. Maybe it will collide with a planet and deliver its ancient organic molecules to a new world, seeding life in a place that doesn't yet have it. Or maybe it will just drift forever, alone in the void, carrying its ancient chemistry through the expanding universe until the stars burn out and reality goes dark. We'll never know, but for a brief moment, for a few months in late 2025 and early 2026, it was here. It passed through our solar system. It came close enough for us to see it, to study it, to understand what it is. And in doing so, it told us something profound about the universe. It told us that the cosmos is bigger than we imagined, that there are trillions of star systems out there, each with their own stories, each with their own chemistry, each with their own potential for life. It told us that we're living in a golden age, a brief window of cosmic history when the universe reveals itself, when we can see distant galaxies before they disappear, when we can detect interstellar visitors before they fade. It told us that we're alone in a way that cannot be fixed, trapped in our observable bubble, surrounded by infinite things we can never reach. But it also told us that we're precious, that consciousness is rare, that the ability to look up and understand is a gift that might be unique in our entire observable universe. And it told us that the tiny corner of reality we do have access to, this planet, this solar system, this moment in time, is worth cherishing because it's all we get. The James Webb Space Telescope showed us that we've been seeing 1% of what's actually out there, that the universe is 100 times bigger than we thought. That reality is always larger than our tools for observing it. And I ATLAS, this ancient messenger from a dead star system, showed us what that scale actually means. It means we're small, but it also means we're witnessing something extraordinary, something that will never repeat. Something that makes this moment, right now, precious beyond measure. So look up tonight, find that faint green glow if you can, before it fades, and know that you're seeing something that traveled for millions of years just to pass through your sky. You're seeing a messenger from the deep cosmos, and the message it carries is this: the universe is vast. You are small, but you are here, you are aware, you are witnessing, and that's enough. That has to be enough, because it's all any of us will ever get.